Hey everybody, I hope you had a great day yesterday with simplifying the radicals using conjugates. Today we're going to talk a little more about what we can do with radicals, with performing operations with radicals. So the way that this works is to combine radicals, you need like terms. So it's like when you add 2x plus 3x, they both have x, so you're able to add the coefficients number in front. Same thing's happening here, but instead of the same variable, you need the same radical. So for instance, for a here, we have 5 square root of 7 plus the square root of 11 minus 8 square root of 7. You always want to look to make sure that you can simplify, that all of the radicals are simplified as far as they can be. 7, 11, and 7, they're all prime numbers, so they're not going to have any perfect square factors. If they did, we'd have to split them apart to bring them to their simplest form before we combine them. In this case, though, we have 5 square root of 7 and negative 8 square root of 7. Those are like terms. So this and this are like terms, so we can combine them. So we add the numbers in front. So 5 and negative 8 make negative 3. So I have negative 3 root 7. And then I can't combine this because it's not a like term. So I just write plus square root of 11. And that's it. That's your answer. The same thing works for cube roots. So for this one, we have 6 cube root of x plus 2 cube root of x. These are like terms because x is in both of the cube root symbols. So we just add the number in front. So as if I have 6 cube root of x's and 2 cube root of x's, together I have 8 cube root of x's. Okay, so that's what we do when we have some radicals that are like terms already. We'll see with the next problem here that it doesn't look like I have any like terms between 10 root 5 plus square root of 20, but I can simplify the square root of 20 to become something different. So what perfect square factor goes into 20? If you said the square root of 4, you'd be correct, because I can break up the square root of 20 into the square root of 4 times the square root of 5, which would give me 2 root 5. So I'd have 10 root 5 plus 2 root 5, and so together that would give me 12 root 5. Alright, and so that would be my final answer. So it didn't look like I could simplify it the way it was at first, but I was able to once I split it up. For D here, there's actually two options of what I can do. I can distribute the square root of 5 to both things if I wanted to, making this the square root of 15 and this 75 times 5. But you always want to look at it first and see, is there anything you can do to simplify any of them? Well, 5 and 3 can't be simplified, but 75 can. And the reason 75 can be simplified is because 25 is a perfect square that goes into 75. So I have this minus the square root of 25, square root of 3, and the reason this usually works out in your favor is because you'll notice once I simplify the square root of 25 square root of 3, I will get 5 root 3. Now I have like terms inside of here. 1 root 3 minus 5 root 3 is negative 4 root 3. So the square root of 5 times negative 4 root 3. And then when I multiply the square root of 5 times this, there's a 1 in front of here that multiplies the negative 4, which would be negative 4. And then 5 times 3, which would be 15. So negative 4 root 15 would be your final answer for this one. All right. So we got a couple problems for you to do on your own here. There's 6 of them. So why don't you go ahead and do them and press pause, and when you're ready, press play and you'll see the answers come up on the screen. Okay, for this one here, we have some like terms already. 3 root 2 and 10 root 2 can be combined to make 13 root 2 minus square root of 6. 6 cannot be broken up, I know you might be saying, well, what about 3 and 2? Well, 3 and 2, neither one of those is a perfect square, so we can't separate those because it doesn't have a perfect square factor. So our final answer would just be 13 root 2 minus the square root of 7. Now this one here, it doesn't look like we have like terms, but 63 has a perfect square factor. 63 can be broken up into the square root of 9 and the square root of 7. So 9 is 3, so 6 times 3, because this would be 6 times the square root of 9, so 6 times 3 is 18. So I have 18 square root of 7, and then 4 square root of 7 minus that. So I have negative 14 root 7. For this one here, we have like terms already with the cube root of 5x for both of these. So 4 minus 11 is negative 7. Cube root of 5x. For this problem, it's the same as before. We have the option whether we want to multiply through 3 times both things and then try simplifying. I find it easier to try to see if you can simplify this first, which I can because the square root of 32 can be broken up into 16 and 2. So I could have that as 7 root 16 root 2. And then the square root of 16 is 4. 7 times 4 is 28. So this becomes 28 root 2. 8 plus root 2. And then a square root of 3 in front. So now we can distribute it. We can combine it first, whatever we want to do. Let's just combine it first. So then we'd have the square root of 3 times 36 root 2. And then 3 times 2 is 6. So that will give us 36 root 6. Alright. For the next one, we have 2 root 5 minus 4 squared. So, we're going to write 2 root 5 minus 4 times 2 root 5 minus 4. Alright, now remember, we're going to do the FOIL method, the first outside inside lots. We're going to multiply. We're not just squaring this minus squaring this. That's not what we're doing here. We have to multiply everything out. It's a double distribution property. So 2 square root of 5 times 2 square root of 5 makes 4 square root of 25, which will simplify that further. 2 square root of 5 times negative 4 would be negative 8 root 5. And negative 4 times 2 root 5 would again be negative 8 root 5. And negative 4 times negative 4 would be positive 16. So this would become 2 times 5, which would be 10, right? Because 4 times the square root of 25 is 4 times 5. 4 times 5, which is 20. And then 20 plus 16 is 36. And so I'd have negative 16 root 5 minus or plus 36. Alright, so again, 4 times 5 is 20. 20 plus 16 is 36. Negative 8 root 5 minus 8 root 5 is negative 16 root 5. And for this one here, we can simplify what's inside of here first if we wanted to, or let's distribute it first. We'll do it differently this one. Doesn't matter which way you do it, but this would give me the cube root of negative 8. This would be minus the cube root of negative 64. So the cube root of -8 is -2, minus cube root of -64 is -4. So that would be -2 plus 4, which is 2. So our final answer is 2. So whether you simplified this first into 2 cube root of 2, making this -1 cube root of 2, and then multiplying that times negative cube root of -4, either way, you're going to get this as the answer. So it doesn't matter which way you go with it, this will be your final answer. So that is operations with radicals. If you have any questions, please either attend the open meet or write them down in the 9.1 questions and try out the BIM for today. Good luck to everybody. If you have any questions, let me know. All right, guys, have a good day.